Day 362 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 76, minimum window substring. The difficulty level is hard, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. Given two strings S and T of lengths M and N respectively, return the minimum window substring of S such that every character in T, including duplicates, is included in the window. If there is no such substring, return the empty string. The test cases will be generated such that the answer is unique. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have the input S equals a string Adobe Code Bank, or ADOBECODEBANC, and T equals ABC. The output is BANC or bank, however you want to say it, and the explanation says the minimum window substring BANC includes ABC from the string T. So let's break this down one step further, y'all. So in our input T, we have ABC. That means we want to find a substring in S that includes every letter in T, A, B, and C, but not just not just any substring. It has to be the minimum window substring or the smallest substring possible. Because if you come right here, you see we could have this right here. This could be a substring that has all of the characters in T, A, B, and C. As an A right here, a B right here, and a C right here. But as you can see, this substring has 1, 2, 3, 4, 5, 6 characters, whereas this substring right here also includes every letter that's in T. It has an A right here, a B right here, and a C right here. And this substring only has 4 characters, right? So we want the minimum window substring. So we want the substring with the smallest amount of characters. And in this case, that happens to be this BANC right here. So that's why the output is BANC, because it's the smallest window or substring that we can create with all of the characters that are in T. So let's go ahead and take a look at example 2 in case they try to get a little tricky with us, right? So in example 2, we have the input S equals a string A, T equals a string A. The output is A. It says the entire S is the minimum window. So S, it's just one letter in A and T. So since A is the entire substring, we could just return A since that's the only letter in A or T, right? And so that's all we have to do is return A. So let's look at example 3 where they might try to throw another little trick question our way, right? So in example 3, we have S equals a string A, T equals a string AA. This time the output is a blank string. It says both A's from T must be included in the window. Since the largest window of S only has one A, we return an empty string. Remember, guys, up here it says S such that every letter and character T, including duplicates, is included in the window, right? So, right, main point, including duplicates, right? In this case, we have duplicates A, right? But only one A is in the input S. And since there are duplicate A's in T, we would need duplicate A's in S. But since there's only one A in S and we cannot create a valid substring with all of the letters that are required, we just return a blank string. So I hope that makes sense to y'all. Maybe if it doesn't, hopefully when we get into the solution, we can make it make sense a little bit more. And now, guys, you know what time it is. It's time to get into the fun part, the actual solution, y'all. So let's get started. Now, the first thing we're going to do is we're just going to handle a case. If T is empty, then we can return an empty string immediately. So for that, we could just say if T equals a blank string, then we could just open up the brackets and we can return a blank string just like that. Now we need to convert the input strings into arrays of characters, which will make it easier for us when we're indexing or going through each character in the string. So for that, we're going to say declare a variable. We call that S array, and we can set that equal to an array parentheses s, that's going to turn s into an array. Then we can declare another variable called t_array and set that equal to an array, parentheses t, and that's going to turn t into an array for us. Now we need to create some dictionaries. One dictionary to store the frequency of each character in t, and another dictionary to store the frequency of each of characters in the current window of s. So for that, we're going to declare a variable called count t. We'll set that equal to a dictionary, a character, colon, int, put the parentheses outside like that. Then we're going to declare our other dictionary that's going to store the frequency of characters in the current window of s. So we can come right here, declare a variable. We could call it window, and we'll set that equal to a dictionary, once again, of character, colon, integer. Come outside of that, put the parentheses like that. And now it's time to populate our count t dictionary with the frequency of each character in t. So for that, we're going to come right here. We're going to say for c in t array. We're going to open up the brackets. We're going to say count t square bracket c comma default colon 0. So that's going to, so what this is saying is for character in t array. So for each character, we're going to set the default value to 0. But each time we see it, we're going to say plus equals 1. So we're going to add, we're going to count every time we see this character. Boom. We're going to add 1 every time we see the character. Boom. Now we need to create another variable of the number of unique characters that we have from t that meet the required frequency in the current window. So to do that, we could just declare a variable and call it have, and we could set that equal to 0. Then we need another variable for the total number of unique characters that we need. So for that, we could just declare a variable, and we could call this one need, and we could just say equal to count t dot count. Boom. Now we're going to create a tuple to store the start and end indices of the minimum window that we have found. So for that, we're going to declare a variable. We call it res. Set that equal to, it's going to be a tuple, so 0, 0. Boom. Now we need the length of the minimum window that we found so far. So we could just come right here. We could declare a variable called res_len for res length, and we could set that equal to int.max just to start. Then we need to create our left pointer for the sliding window. So we're going to come right here, declare a variable, call it L, and we can set that equal to 0 for our left pointer of the sliding window. Now it's time to expand the window by moving the right pointer. So for that, we're going to say for r in 0 ... less than sign array, or excuse me, s array dot count. We're going to open up the brackets. Boom. We're going to declare a variable. We'll say variable, call it c. We'll set that equal to s array square bracket r. Boom. Then we're going to say window square bracket c comma default colon once again. Then we're going to increment it, say plus equals 1. Boom. Now, if this character is needed and its count matches the required count, then we need to increment half. So to do that, we're going to come right here. We're going to say if count t square bracket c exclamation point equals, so does not equal nil, and window square bracket c equals count t square bracket c. We're going to open up the brackets, and we're going to say half plus equals 1. Boom. Now, when all the required characters are matched, we need to try to shrink the window from the left. So for that, we're going to come underneath this, and we're going to say while have equals need, while have equals need, we're going to open up the brackets, and we need to update the result if the current window is smaller than the previous recorded window. So we're going to say if R minus L plus 1 is less than R res len, we're going to open up the brackets, and we're going to say res equals, open up the parentheses, L comma R. Then we're going to come underneath that, and we're going to say res len equals R minus L plus 1. Just like that. We're not done yet, but we're getting there, y'all. We're going to come underneath this if statement right here, and we're going to remove the leftmost character from the window by saying window square bracket S array square bracket L comma default colon 0. This time we're going to say minus equals 1. Boom. Now if the character was required and its count drops below the required decrement half, then we're going to say, or then we need the decrement half, so we're going to say, we're going to come underneath this, and we're going to say if count T square bracket S array square bracket L, come outside both of these square brackets, we're going to say exclamation point equals, so does not equal nil, and two and signs, window square bracket S array square bracket L, come outside of these square brackets, put an exclamation point to unwrap it, and we're going to say is less than count T square bracket S array square bracket L. Once again, come outside of these square brackets, put an exclamation point. Then we're going to open up the brackets, and we are going to say have minus equals 1. Boom. Now we need to move the left pointer to the right. So we'll come underneath this, and we're going to do that by saying L plus equals 1. Sorry, y'all. Now, if a valid window was found, we need to return the substrings. Otherwise, we can return an empty string. So we could come right here, and we could say if res len, this exclamation point does not equal int dot max, then we could open up the brackets. We could say return string parentheses S array, open up the square bracket res dot 0. Then we're gonna say dot 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 res dot 1. Boom. Else we could come right here and say else we're gonna return a blank string by saying, oh, excuse me, don't just put, we gotta say return blank string. Now let's go ahead and run this. Make sure it runs properly. That wasn't too bad, y'all. Okay, we got an error. Let's see. What does it say? It says spelling wrong. Sorry, y'all. Typo. Default. The A comes before the U. Let's run it again. See what happens this time. And it's accepted, y'all. That's what I'm talking about. Let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. Ooh, 54 milliseconds beats 18.82% of users with Switch. We could definitely get those numbers up. And we will get those numbers up as we continue down our LeetCode journey. But today we just want to be able to solve the problem that is presented to us. And I feel like this is a good solution for that, y'all. So make sure you get one more look at the code. It's a lot of code, but it's not a lot of code, but it's a little lengthy. So this the top part. Then this like, we're not done yet. This like some of the middle part. Oh yeah, that's the middle part. And this the bottom part. Boom. And yeah, y'all, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.